Hello guys, trust you're doing fantastic. Now in today's video, let's talk about how we can convert hexadecimal number system to octadecimal number system. So let's consider this example that says AF dot 2b base 16 equal to x base 8, find x. Now we know the relationship between hexadecimal number system to binary number system is represented using 4-bit binary coding system, so which is represented as 8421. So this is the code we're going to use to convert hexadecimal to binary. Now for we to do this, we need to represent A. So A is nothing but 10. So in that case, we're going to have 1 0 1 0, which will give us 10. Now F is nothing but 15. So we're going to have 8 is going to be 1, 4 is going to be 1, 2 is going to be 1, and then 1 is going to get 1. So this will give us a total of 15. Then we have the dots, and then 2 will be 0 0 1 0. Now using this code, B is 11. So 11 is going to be 1 0 1 1. So using this, so if you sum this up, you're going to get 11. So in this case, we need to convert. Now we have the binary equivalent of this value in hexadecimal number system. So this is the binary equivalent of it. Now we need to convert this binary equivalent of it into octal. So all we need to do is that we need to remember that we need to introduce what we call. Now the values before the decimal point, we have to group from right to them in the group of 3, because we're converting from binary to octal. So we need to group them in a group of 3. In a situation whereby we don't have up to 3 in a group, we need to introduce what we call padding. Now for the values after the decimal point, we have to start grouping from left to right, and we're also going to apply 0 padding in a situation where we don't have up to 3 values in a group. Now let's begin with the values before the decimal point. Now we begin to group into 3. The first group is this. We have one group. The second group is this. We have 2 groups, and then the last group will be this. We have just 0 and 1, so we need to introduce one more 0 padding so that we can have another group. So this is typically the same with what you have down, but just want to explain to you so that you can understand. And then let's consider the values after the decimal point. We have to group from left to right, so we group them in 3s. Okay, this is the first group. The second group, we have to group, we count 1 2 3. Now for the third group, we have just 2 values. We need to introduce 0 padding so we can have up to 3 values in the group. So we have this 3. So if you notice, this is equivalent to what we have here. All right, so this is equivalent to what we have here, and then this third group is equivalent to what we have here. Now after the decimal point, this is equivalent to what we have here. This is 0 1 0 equivalent to what you have here, 0 1 0. Then this final group is 1 1 0 is equivalent to what you have here. Now the arrow tells us the direction of our grouping. So like I said, we group from left to right this way, and then for these values before the decimal point, we group from right to left this way. So the arrows indicate the direction of grouping. Now let's simplify these values. Let's find the equivalent of these values in octadecimal number system. We know the relationship between binary number system and octal number system is 3-bit binary coding. So what we need to do is we need to get the equivalent of this. 0 1 0 means 0 1 0 is going to be 2. For the next group, we have 1 0 1. 1 0 1 is going to be 5. Then for the third group, we have 1 1 1. If you sum everything together, 4 2 1, we're going to get 7 dots. Now after the decimal point, we have 0 0 1. 0 0 1 is going to give us, when you sum everything up, 001, it means we're going to have 1. For this other group, which is 010, if you sum everything up, you're going to notice that we'll just have only 2 on. So you have 2. Then the last group, you have 110. If you sum everything up to 110, it's going to be 4 plus 2, 6. So you have 6. So you have it base 8. So this is how to get the equivalent, how to convert hexadecimal number system to octal number system. So this is the octal number system equivalent, which is 257.126 base 8. This is how simple it is to convert hexadecimal number system to octal number system. Now let's take another example where we have to convert octal to hexadecimal number system. You have this example that says 72.1 base 8 equal to x base 16, find x. Now we're converting octal to hexadecimal. Like I said, the procedure is that we need to pass through a mediator. It means we need to convert first to binary, and from binary we need to convert to hexadecimal. Now let's begin. Let's take it a step at a time. Now for we to convert this to hexadecimal, first we pass through a mediator which is known as the binary, and the relationship between octal and binary is 3-bit coding system. So we have 421. So all we need to do is to represent octal number system in binary number system. So this is very easy. So all we need to do is to use this. So in this case, we're going to have for 7, we're going to have all these values. 4, 2, 1 will give us 7. So we're going to have 1, 1, 1. So if you sum everything up together, you're going to get 7. So for 2, it means we're going to have 0, 1, 0. So have 0, 1, 0 dot. For 1, we're going to have 0, 0, 1. We'll have 0, 0, 1. So this is the binary equivalent of the octal number system. Now we need to convert the binary equivalent into hexadecimal, and we know the relationship between binary and hexadecimal is represented using 4-bit coding system. So in this case, it means that we need to group these values in binary into groupings of 4 in order for we to derive the value in hexadecimal number system. Now let's do that. Like we know the rules, we already know the rules. The values before the decimal point we have to group from right to the left, and we have to group them in 4s. So we have 1, 2, 3, 4. So this is going to be one group. Now we have just 2 values left. In a nutshell, we have to do what we call zero padding. So we have to add 2 zeros. So once you do that, we have 1, 2, 3, 4. So we have 4 values in one group. Now let's go over to the values after the decimal point. We have 1, 2, 3, just 3 values. So what we need to do is that we need to include 1 zero padding. Alright, so we have 4 digits, so it's easy for you to group in 4s. Alright, so in this case, if you notice, this is similar to what we have here. We have 0011, which is the first group, and then 1010, which is similar to this 1010, the second group, and after the decimal point you have 0010, 0010. So this is similar to what we have here. So if we have to decode this to represent this binary digit that has been padded and grouped into hexadecimal, it's very easy. So we need to know the relationship. The relationship is 4 bits. Now let's get started. You have 0011, so it means 8 is going to be 0, 4 is going to be 0, 2, 1, 1 is going to be 1. So it means if we sum it up together, 2 and 1, we're going to have 3. So we'll have 3 there. Now for this coding, we have 1010. 8 is on, 2 is on, so that's 10. Dot, we have 0010. It means only 2 is on, so in that case we have 2. So therefore the equivalent is going to be 210.2. Remember what I told you, whenever you're representing your values in hexadecimal number system, 10 should be replaced with the alphabetical representation, which is E. So 10 represent A. So we're going to have 3A.2 base 16. So this is the right way to write your answer. Now don't leave your answer as 310.2. It means something different totally. So this is how you can do a simple octal conversion to hexadecimal number system. Now let's consider this interesting example. If into bracket 11x 1y base 8 equal to 12c 9 base 16, find the values of x and y. So in this case we have two unknown values, which is x and y. They are unknown. So this problem is talking about octal number system and hexadecimal number system. So it means that we need to represent the hexadecimal number system in octal number system. So since we know the O values in hexadecimal number system, which is 12C9, we know what C represents. C represents 12. So therefore we know the values on the right hand side. So what we're going to do is that we're going to take this value, which is the hexadecimal number system, and convert it to octal number system so that we can tell what is the value of x and y. So for we to convert hexadecimal number system to binary, we need to understand that we require 4-bit coding system to represent that. So since we know that, we need to go straight to represent this value. So 1, we know what 1 is going to be. So 1 is going to be 0, 0, 0, 1. So this is going to be the representation in binary. 2 is going to be 0, 0, 1, 0. So C, which is 12, is going to be 1, 1, 0, 0. 9, which is going to be 1, 0, 0, 1. So this is the equivalent in binary. Now since we know the equivalent in binary, we need to convert this binary equivalent into octal number system. Now for we to do this, we need to understand that we need to represent 3-bit system in order for we to get the octal number system. So we need to perform what we call grouping and padding. Now since we don't have a decimal point in this value, it means we need to start grouping from right to left. And if there is any case where we don't have a complete value in a group, complete 3 values in a group, we need to introduce padding. So in this case, let's begin. So we have 1, 2, 3. So this is our first grouping. It has 3 digits in a group. The second grouping is this. It has 3 digits in a group. The third grouping, it has 3 digits in a group. We have the fourth grouping. It has 3 digits in a group. Then we have the fifth grouping. It has 3 digits in a group. And then we have this 0 left. So we need to introduce 0 padding, add 2 more zeros so that we can have a complete group. Now if you check, we have done this grouping in this direction. Okay? Showing that we have moved from right to left. Now if you notice, it's equivalent to what we have below. This is this, 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 and this final one is this. Now in order for we to represent this, so we're going to have 0, 0, 0 will give us 0. 0, 0, 1 will give us 1. 0, 0, 1 will give us 1. 0, 1, 1 will give us 3, which is 0, 1, 1 will give us 3. 0, 0, 1 is going to give us 1. 0, 0, 1 is going to give us 1. Now you have to follow this code. Now it means that our value will be, now you can omit this first 0. It has no significant value in this, so you can omit it. So what we're going to have 1 1 3 1 1 base 8. So in a nutshell, we can write that 11311 base 8 is equals to 11x1y base 8. Now we're looking for x and y. So x in this place is going to represent 3. So x is going to be equals to 3. And then y at this position represent 1. So y will be equals to 1. So this is how easy it is to solve this kind of equation. So this is the end of today's topic. So pay close attention to the subsequent videos in this channel. Alright then, enjoy this video.